the change of a scale property? Change of a scale property of a Laplace transform of any function ft. Here we assume that ft be of a class A function, ft be a class A function means there exists a Laplace transform of a ft. So, what is the, in form of a theorem, what is the change of a scale property if Laplace transform of a ft equal fs, then Laplace transform of a f of at, where a is any constant, equal 1 upon a f of s by a, s by a. Now, how we prove this one? Prove this one, we use the definition of a what? Definition of a Laplace transform. Now, by definition of a Laplace transform, definition of Laplace transform, by definition of Laplace transform, Laplace transform of a f of at equal 0 to infinite e to power minus st f of at dt, f of at dt. Now, here we assume that we try to convert here from one variable to another variable, means from t to u. So, here we assume that let at equal u, at equal u, then what is the t? This implies that t equal u by a, u by a, and what is the lower limit? Lower limit, if we put t equal to 0 here, if t equal to 0, then what is the value of a u? If we put here t equal to 0, a into 0 equal what? Then this implies that u equal to what? U equal to 0. And if t equal to infinite, means a upper limit, then t equal to infinite, into a become infinite. This implies that u equal to what? Infinite, means a lower limit and upper limit become 0 and infinite. And what is the value of a dt? dt equal du upon a, du upon a. Now, we put these values, lower limit and upper limit, then what will happen? This integration become, lower limit become 0, upper limit become infinite. E to power minus s, in place of a t we write u upon a, in place of f of at, here f of at become f of u and dt become du upon a, du upon a. Now, here 1 upon a be the constant, so this become outside from the integral sign, 1 upon a, 0 to infinite, e to power minus s, and here u by a, f of u du. So, now again we use the definition of a what? Definition of a Laplace transform. What is the definition of a Laplace transform? E to power minus st ft dt equal fs. So, here this one is a given. Laplace transform for ft is a fs. So, what is the value? What is the value for this one? Means here we able to find out what? Laplace transform of f of at equal 1 upon a, 0 to infinite, e to power minus s u by a, or we write s by a u, f of u du. And what is the given? Given is a Laplace transform of ft is a fs, and obviously Laplace transform of ft is a 0 to infinite e to power minus st ft dt equal to what? Fs. So here if you closely observe, here s, then s, but here variable is either we write a u or t, doesn't matter, means either we write e to power minus s by a t ft dt, because if we put u equal to t, then this become du equal to dt and limit does not change. So by comparing first and second, which one is a given, we able to find out what? 1 upon a f of s by a, f of s by a. So this one is a Laplace transform of f of at. So this one is a proof. This one is a proof. So what is the application of a change of a scale property? So if we have a Laplace transform of ft and we try to find out a Laplace transform of a f of at, means multiplied by any constant in a t, then what is the Laplace transform? Laplace transform is a 1 upon a, and if we replace s by a, then we able to find out a Laplace transform of a f of at. This one is a what? This one is application of a change of a scale property in order to solve any numerical problem. So now next we are going to solve two numerical problem based on a change of a scale property, means by using the change of a scale property we try to solve. First example is a what? Evaluate Laplace transform of a sine 5t. Evaluate Laplace transform of sine 5t. Second one is if Laplace transform of ft is a 1 upon s e to power minus 1 upon s, then prove that Laplace transform of e to power minus t f of 3t equal e to power minus 3 upon s plus 1 upon s plus 1. Now we find the solution of a first problem first. Let here let ft equal sine t, sine t. Here we assume that ft equal sine t, because here sine at, a is a what? A is a 5. Here we are going to use we are going to apply the change of a scale property by knowing the value of a. Here the value of a is a what? Value of a is a 5. That's why here we write ft equal sine t. So what is the Laplace transform for this function? Now let ft equal to sine t, then Laplace transform for ft equal Laplace transform of a sine t, this one equal, as we know that this one is a by the standard result, means elementary Laplace transform of elementary function. Laplace transform of a sine t is a 1 upon s square plus 1 square, and 1 square become 1 provided s is a greater than 0. Provided s is a greater than 0. S is a greater than 0. So now we apply the change of a scale property. Now Laplace transform of a f of 5t, f of 5t, or Laplace transform of a sine 5t equal what? By change of a scale property, this become 1 upon 5, 1 upon a. In place of a write what? In place of a we write of 5, and suppose here we assume that this one is a what? Laplace transform of ft is a capital Fs. So 1 upon a f of, here we write s by a, s by 5, s by 5, s by 5. So f of s is a 1 upon s square plus 1. So what is a f of s by 5? In place of a s we write s by 5. So this one is a A by S or S by A? S by A. Okay, sorry. So, this become, so in the next phase we are going to write Laplace transform of a sin 5t equal 1 upon 5 into 1 upon s by 5 whole square plus 1. If we simplify, then this become what? This become 1 upon 5 into 1 upon s square plus 25, and in a numerator this become 25. This one cancel out, then this become what? 5 upon, here we write 5 upon s square plus 25. So, this one is a answer provided what? S is a greater than 0. This one is the answer. We may also able to directly find the Laplace transform of sin 5t using the elementary function, Laplace transform for elementary function, because this one is a sin 80 and the Laplace transform for sin 80 is a upon s square plus a square, and here a is a 5, so 5 upon s square plus 25. But here we try to find out the Laplace transform of a sin 5t using the change of a scale property. So, directly we also able to write the Laplace transform for sin 5t, also be able to find out the Laplace transform of sin 5t using the change of a scale property. Now, second question is if Laplace transform of a ft is a what? Laplace transform for ft is a 1 upon s into e to power minus 1 upon s. 1 upon s into e to power minus 1 upon s. Then using the change of a scale property, prove that what? Then prove that Laplace transform of e to power minus t f3t equal e to power minus 3 upon s plus 1 upon s plus 1. So, we are going to prove this one. If Laplace transform of ft is a 1 upon s into e to power minus 1 upon s, then Laplace transform of f of 3t equal 1 upon 3 into f of s by 3, and here we assume that Laplace transform of ft is a fs, because what is the change of a scale property? Laplace transform for f of at equal 1 upon a f of s by a. So, here we replace s by 3. So, what will happen here? This become 1 upon 3 into 1 upon s by 3. S by 3 in place of a s we write s by 3 into e to power minus 1 upon s by 3. Now, if we simplify this result, then 3 by s, 3 cancel out, this become 1 upon s into e to power minus 3 upon s. Now, what is the question? Question is find the Laplace transform for e to power minus t f of 3t. Now, we find the Laplace transform for f of 3t. Laplace transform for f of 3t. Now, in order to find out the Laplace transform of a what? Laplace transform of a e to power minus t f of 3t, f of 3t, we use the what? We use the first shifting property. What is the first shifting property? E to power at is a what? 1 upon f of s minus a. Means in place of a s we write s minus a if e to power at. But here what is the value of a? A is a minus 1. A is a minus 1, so we replace what? We replace s by s plus 1. So this one become 1 upon s plus 1 into e to power minus 3 upon s plus 1. Here we write by first shifting property. By first shifting property. Shifting property. First shifting property. And what is the first shifting property? E to power at, e to power at ft dt. Laplace transform of e to power at ft dt is f of s minus a. If Laplace transform of ft is a what? Fs. If Laplace transform of ft is a fs. Laplace transform of ft is a fs. So in this way we able to prove this one. So this one is a result. E to power minus 3 upon s plus 1 upon s plus 1. So now we able to prove this one. So this one is a result. This one is a answer. This one is the answer, or we say this, we able to prove this one. So in this way, in order to find out the Laplace transform, we able to apply, we use the change of a scale property in order to solve the numerical problem. So in this way, we able to find out a Laplace transform of a e to power minus t f of 3t. Here we use the two property. One is a change of a scale property, and second one is a first shifting property. So this one is a what? This one is a change of a scale.